Assalamualaikum warahmatullahi wabarakatuh. Good morning, Memusi. Good morning, all my friends. Um, Today, I will present about the physical properties of the solutions. But first, let me introduce myself. I'm Muhammad Rafli Aditya from PKB 2019. And now, why I wanna bring this material to my presentations? Because the solution is around us. Every day, we meet with the solution and their properties, namely the colligative properties of the solutions. We must know the types of the solution and the properties of solutions to facilitate us in our daily activities. A. Type of solution. According to Chang 2005, the type of solution based on the ability to dissolve something is divided into three. First, saturated solution is a solution containing the maximum amount of solute in a solvent at a certain temperature. Second one, unsaturated solution is a solution that contains less solute that is ability to dissolve. The third one, supersaturated solution, is a solution that contains more solute than is contained in saturated solution. B. Dissolution process from a molecular viewpoint. When a solute dissolves in a solvent, solute particle will spread throughout the solvent and will occupy the position normally occupied by the solvent molecule. The ease with which solute particle replace solvent molecule depends on the relative strength of the three types of interactions. First, solvent-solvent interactions. Second, solute-solute interaction. Third, solvent-solute interactions. If the interaction between solvent-solute is stronger than the attraction between solvent-solvent and solute-solute, the dissolution process will take place. In other words, the process is endothermic, or enthalpy solution less than zero. If the interaction between solvent-solute is weaker than the interaction of solvent-solvent and solute-solute, then the endothermic process will occur, or enthalpy greater than zero. Then, why do solutes dissolve entirely in the solvent when the attraction between their molecule is stronger than the attraction between the molecule of the solute and the solvent molecules? The dissolution process, as well as, as all physical and chemical processes, are influenced by two factors. The first factor is energy, which determines whether the process is exothermic or endothermic. The second factor is the intrinsic tendency towards disorder in all occurrence in nature. When solute molecule and solvent molecule are mixed together to form a solution, of irregularity will increase. In the pure state, solvent and solute have a fairly high degree of order, as seen from the fairly regular arrangement of atoms, molecules, or ions in three-dimensional space. This high regularity will be destroyed if the solute dissolves in the solvent. So, this So the dissolution process is accompanied by increased irregularity or randomness. It is increased system disorder that causes any substance to dissolve even though the dissolution process is endothermic. The next, solubility. Solubility is a measure of amount of solute that will dissolve in solvent at a certain temperature. This means the amount of solute added to the solvent until it reaches the maximum limit for dissolving. The phrase like dissolves like help us predict the solubility of substance in a solvent. This expression states that two substances of the same type and magnitude between molecules will tend to dissolve one another. For example, ionic compounds will be more soluble in polar compounds. C. Concentration unit. Solution concentration is the amount of solute present in a certain amount of solution. There are several types of concentration unit. First, percent of mass. Percent of mass is amount or percentage of mass of solute in a solution. The formula is percent mass equal to mass of solute over mass of solution multiplied by 100%. Second is molarity. Molarity is number of mole of solute in 1 liter of solution. The formula is molarity equals to mole of solute over the volume of solution in liter. So, molarity has unit of mole per liter. The third is molality. Molality is number of moles of solute dissolved in 1 kilogram of solvent. The formula is molarity equals to mole of solute over the mass of solvent in kilogram. D. The colligative properties of the solution. As you can see, the colligative properties divided into four. First, vapor pressure lowering. The second, boiling point elevation. The third is a freezing point depression. And the last one, osmotic pressure. First is vapor pressure lowering. If a solute is not volatile, the vapor pressure of the solution is always smaller than the vapor pressure of the pure solvent. This is explained by Raoult's law, which states that the partial pressure of the solvent from solution is the pure pressure multiplied by the mole fraction of the solvent in solution. The formula is the pressure of solvent equals to mole fraction of the solvent in solution multiplied by pure vapor pressure. Why is the vapor pressure of the solution lower than the vapor pressure of the pure solvent? One of the causes of physical and chemical process is the increase in irregularities. The more irregular, the greater tendency for a process to take place. Evaporation increases the irregularity of system because the molecules in the vapor phase are less regular than the molecules in the liquid phase. Because the solution is more regular than the pure solvent, the difference between the irregular between the solution and the steam is smaller than between the pure solvent and the vapor. So the solvent molecules are less likely to leave the solution than leaving the pure solvent to become vapor, and the vapor pressure of the solution is smaller than the vapor pressure. Second, boiling point elevation. Because the presence of non-volatile solutes reduces the vapor pressure of the solution, the boiling point of the solution must also be affected. The boiling point of the solution is the temperature at which the vapor pressure of the solution is equal to the pressure of the outside atmosphere. As you can see, the formula is the change in boiling point equals to the boiling point constant multiplied by molality. The third is freezing point depression. Freezing involves the transition from an irregular state to an orderly process, so that the energy process must be taken from the system. Because the solution is more irregular than the solvent, more energy must be taken from it to create order than in the case of pure solvent. So the solution has a lower freezing point than the solvent. Note that is the solution is frozen solid separated is the solvent component. The formula, as you can see in your display, is the freezing point change equal to freezing point constant multiplied by molality. The last one is osmotic pressure. Osmotic pressure is the pressure needed to stop osmosis. Osmosis means the net movement of a solvent molecule through the semi-permeable membrane from a pure movement or from aqueous solution to a more concentrated solution. The formula is P equals to molarity multiplied by gas constant and multiplied by temperature. E. Example of the colligative properties of solution in daily life. The first, vapor pressure lowering, that is floating pool and salt level in Dead Sea. The second is boiling point elevation, that is distillation and adding salt when cooking food. The third is freezing point depression, that is making soft ice cream and antifreeze on the car radiator. The last one is osmotic pressure, that is dialysis machine and food preservation. That's all from me. Apologies me if there are many mistakes in pronunciations, and thank you.